Hello, my name is Grant Heimbach, and I'm a LabVIEW Product Manager. With me today is Mark Ramsdell, who's going to be discussing the Certified LabVIEW Architect Exam, or CLA exam, our highest certification course, and preparation for that exam. Mark, why don't you tell us a little bit about yourself?
Thank you, Grant. I'm the Certification Project Manager here at National Instruments, and today I would like to go over with you in detail preparation for becoming a CLA, to take the CLA exam. So first we'll look a little bit at the objective of the exam and what it means to have a CLA. We'll talk about the process for signing up, taking the exam, sitting through it. It's a 4-hour exam, by the way. And we'll talk about the format of the exam, the specification that you'll be reading, and how this exam will be graded. Then we'll get into the details and talk about what do we expect, what kind of deliverables there are for the CLA. Afterwards, we'll look at some of the preparation resources and exam tips. But since we're doing a recording, we won't be taking any of your questions today. Here's the overview of the CLA exam. Let's dive right into the details. What skills are demonstrated? First off, a mastery in analyzing and interpreting the requirements. You'll be provided a specification, and you'll have to read through that and determine how to proceed with creating an application. We'll be looking for you to create an application that is designed for a team to take over and complete. This application needs to be scalable, as we often require in LabVIEW. We're looking for a lot of modularity within the product hierarchy so that we can split off different functionality in different sections to different teams of developers to be able to complete the work.
So Mark, the lowest level of certification is Certified LabVIEW Associate Developer, or CLAD, and then the middle certification is Certified LabVIEW Developer. The CLAD exam is multiple choice format, basic knowledge of LabVIEW.
Correct.
The CLD is the big step function, and the difference in the test is CLD is actually development. So you actually spend your 3 to 4 hours actually developing code. What's the big difference between CLD and CLA in their format?
Well, that's a great question. So the easiest discussion point there is that the CLD requires a functional application and that it is graded based on its functionality. And we do have some interesting webcasts that discuss that in detail. However, with the CLA, we're looking for your ability to create a plan for other developers to go and complete and create functionality. We're not looking for an application that runs and performs functionality, and we'll talk about that in a little bit of detail. However, we're also looking for your ability as an architect to tell other people, to give them instructions and documentation, design patterns, and an architecture that they can take and finish out.
Okay.
So it's quite a step function in difference between the CLD and the CLA also. In this exam, as we were mentioning, I'm going to go on to the next bullet. We're also looking for you to create the data structures and interfaces by which the developers will complete the application. We'll also be asking for you to document in the code where the requirements from the specification are satisfied. And we'll be talking about how these tags or labels, we'll call them tags, are used, and how requirements gateway is used in grading to find all the tags and allow the grader to go through and evaluate the use of those tags. And to finish up, we did talk about the documentation. We're looking for documentation on how the developer, who might be in another country or across the United States, a different state, a different time zone, could take this code and read the instructions and be able to complete the application as you have intended it as the architect. Let's talk about the process a little bit. You'll be given the latest version of LabVIEW. For the time of this recording, it would be 2013. We'll also be allowing you to use the LabVIEW help and any documentation that ships with LabVIEW. Anything that comes with LabVIEW is fair game. You'll not be allowed to bring in other a USB, any code. You will not be allowed to download items from the internet, no OpenG, none of that will be allowed. And we'll be giving you also 4 hours.
So what about templates and sample projects that were introduced, I think, in LabVIEW 2012?
Well, those are all fair game because they ship with LabVIEW. Let's take a look at the format. You'll see this in the sample exams that we provide, that you'll be given a project that's based on one of the CLD projects. And we discussed these in the preparation material for the CLD, the different models or scenarios that are possible that you will see for your exam. inside the spec, we give you a layout of the user interface, sort of a napkin sketch, as you would say. Maybe you're talking with your client or with your manager, and they're kind of sketching out what they would like the application to do. In addition to that, you'll be given the functional requirements. What is this application supposed to do? What controls are supposed to do? What indicators turn on and off? What is the behavior of the model? You'll also be given a text file that includes all the labels that will be used to document in the code where the requirements are being met. This is quite convenient since you're not stuck there typing them in. There's a very specific format that's required, and we'll see that a little bit further in the presentation. So, what are you supposed to do then? Given this specification with the UI layout, we want you to develop the project architecture in LabVIEW. We want you to track the requirements in the project architecture at the location where the code satisfies the requirements. We're looking for you to develop the high-level architecture, all of the modules, the architecture or the design patterns for those models, the data structures that are used to transfer the data around the application, and to document how the application works and how the developer should complete the application. And as mentioned before, we're not looking for a functional application. That's a job for the developers who will take over after you've given them this project. Here's the grading. There are 4 main areas that comprise the grading. You can see the values here. The architecture development is the area where we score the most points. We're looking at how the application is run, how front panels are open, how does communication and messaging occur within the project. The requirements coverage is very important. You can see it's got a large piece of the grade percentage. This is your ability to read and understand a specification and then to put into code the requirements that are in that specification. The documentation is the instructions to the developer on how to complete the exam. We use the requirements gateway to record the tags, and we use the VI analyzer to look at the style, and those are very common grades and evaluations that are used.
And the style guideline is in the LabVIEW in product help, so someone could open up LabVIEW help and find that style guideline if they didn't have it handy.
That's correct.
Okay.
Very good. So, and we see also the passing grading is 70%.
Normally, where does the grading take place? Is it regional, or is it all sent back to the United States to be graded?
Yes, so we have global training and certification here in Austin, and all of the exams are graded here. So if you're overseas, they'll be sent back to our team here. We have an operations team to receive and process these exams, and your CLA will be evaluated by 2 engineers.
Normally, how long is that? I know it's variable, but how long is the process from Austin getting the exams and then turning it around and getting a result back to the developer?
You can expect a 4-week turnaround.
A 4-week turnaround?
Yes.
And is the exam localized in any other languages, or is it English only right now?
It is. What you want to do is contact your local branch office to determine the language that's most preferable for yourself.
Okay.
Now let's take a look at the details for the project architecture development. We'll look at the project level, we'll look at some of the deliverables that we are looking for. We'll talk about how the tags are used to show fulfillment of the requirements, and we'll look a little bit more about how documentation is used. So, what is the specification? The specification is a document that comes to you, and it's a model based on one of the scenarios that we use for the CLD exam. In this specification document, at the beginning, we'll have a slight objective, a small objective. We'll have a user interface sketch, again, the paper napkin sketch that everyone likes to talk about, how these great ideas come from that. And it will discuss in the interface, it will talk about what are the sensors for this model? What is the display going to look like? What is the interaction from the user, the human-machine interface that the user takes to press buttons to indicate to the model what it wants to do? Then there's a section on the terms and definitions. This is provided to help get you the mental picture of what this model is. For example, in one of the sample exams, the elevator, it will discuss how this elevator works. You have your experiences with the real-world elevator, but we want to help shape this in the specification so that you know what is supposed to occur for this elevator. So when you read this, it might seem like a lot, but it will help you throughout the 4 hours to have that mental picture of how your model is supposed to work, how your scenario is supposed to work. Now, in this terms and definitions, you'll notice that between the different sample exams, there are some template or boilerplate pieces. These will be the same in your actual exam. The differences are based on what the model is. For example, if you have an ATM or an elevator, which are the sample exams. There will be differences in the functionality portion, but you will notice there are similarities in some of the larger areas or more of the generic areas of the model, and that will carry over into your exam. Then the functional requirements is a long listing based on tags or requirements labels that tell you the details of how this functionality is supposed to occur in your application. So while you're programming your application, you've created your architecture to manage the larger pieces. You'll also have these details of the small pieces that you will set up and then ask the developer to complete. So let's talk about the user interface. There's a main VI that will run the entire application, and within that there will be some simulation interfaces. When we give you the model, we ask you to create a simulation of the model that at some point in the future will be placed with hardware components. We also ask you to create custom controls that apply for your specific application. Within the application framework, as I mentioned, the main VI is kind of the driver. This is how all of the different modules are called. We'll be looking for the data structures that are used within the different modules and being passed between the modules. There should be a series of these modules, and we'll talk in a little bit more detail about what a module is in this context, and the supporting sub-VI hierarchy that might go with those modules. For example, if you have error handling, you might have more than one VI that it comprises the error handling module. We're looking for an icon that has to be somewhat indicative of the functionality and a solid connector pane so that a team of developers would be able to pass data from one module to another module. We're looking for a functional interface, how these modules are to work with each other, and we're looking for you to provide a method so that hardware interface can be put into the application later. So we're not looking for you to develop the hardware interface, we're looking for you to develop the ability for the hardware components to be put in the future. These are the deliverables. In the main VI, again, we're talking about the user interface. You need to pay special attention to this. The user interface might have more than one component. We're looking for driving architecture in the main VI. How does this main VI call these different interfaces? How does it call the modules that support these interfaces? Again, the major data structures are very important. Simply putting in a variant and saying that everything is passed through a variant is not enough. You have to go into the details on how these variants are converted to data and back and forth. We're looking also for event handling, for data handling, timing, and error communication methods. As I mentioned, error handling is an important part of the application. We're looking for documentation that lists the functional details for the developers to complete. We're not looking for you to go to a level where you'll be creating arrays and manipulating array elements. That will be left in the instructions for the developer.
So would you be putting in stub VIs, or a stub VI is a non-functional sub VI, it's just a holding place, or is it just as easy as adding in documentation that a developer will be putting the hardware interface here? Would you actually be adding stub VIs, or is it just documentation that you're looking for the CLA?
So we're looking for a combination of the two. Certainly we could say that LabVIEW is an international language. All of us as LabVIEW developers have the ability to communicate with each other in LabVIEW. However, sometimes a little bit of your native language is also important. So when it comes to stub VIs, we are looking for that. We want a stub VI because we don't want functional VIs. That would take too much time to develop. But on the flip side, we don't want a stub VI that when you open it, there's no code whatsoever, and there's just a short message that says, developer, complete this.
Okay.
So that's a little contrast there between a stub VI. We don't want the full development, but yet we don't want just an empty shell, per se. So we are looking for all of these modules and sub VIs, these stub VIs, to be fully communicated, fully connected with each other. We can't leave it to the developer to decide how the different modules communicate to each other, because if these developers are spread out across the regions, they would each come up with their own version of how to communicate, and it would not be possible to integrate those. So we're looking for that architecture to show the developers what the communication method is, how the modules talk to each other, and what the messaging is.
So in the exam, you as the architect should design, like using queues, for instance, to be able to pass information between loops, or wiring different sequential code together. You would wire them together for the developer.
That's correct.
Okay.
And queues are one of the very popular methods for using for messaging.
Okay.
For the user interface, it's possible, and you'll see in the sample exams, that there's more than one VI to create the interface. There'll be a sensor component, there'll be a display component that's giving information back to the user, and there'll be a console that allows the user to communicate with the application while it's running. So, is this GUI modular? Can one of the modules be swapped out for a hardware piece? Or if you had to bring in the hardware, would that require a lot of programming and developer time to put that hardware in? So we're not looking for that. We're looking for that modularity, that ability to have different components separated out by their functionality.
So you need a pretty scalable architecture to be able to do that.
Yes, that's correct. So here we go. Let's talk a little bit more about these shell or stub modules that we've been discussing a little bit, and sub-VIs. What do they need to have? Without a doubt, the inputs, the outputs, an icon that reflects their functionality, and the connector pane that allows the data to be passed back and forth, sort of the API. The architecture of the module needs to be created. Architecture is a big word. I think at the module level we're looking for a design pattern. It's still a type of architecture, but simply creating a sub-VI and telling the developer to create a, let's say for example, producer-consumer loop is not enough. You need to create that structure of the design pattern for the architect or for the developer to finish out with. They should be able to go in and be able to create cases and have the proper data available to pass in and out of these cases. We're looking for the error handling to be integrated within each of these stub VIs. Simply saying put in error handler is not enough. You need to show the developer how the error handling will be managed, how the errors will be passed through, if there's a centralized or an FGV or some sort of a module of the error handling inside of the other modules. Error handling is very unique in that it most likely as a module will be spread out among all of your sub-VIs. Now, in addition, inside of these stubs, we need the documentation that tells the developer how to complete. So we mentioned earlier that LabVIEW is kind of the international language. To a certain extent, how you set up the design pattern, how you pass messages in, and what data might be carried by those messages is telling the developer how to finish out the application. However, inside each of the cases that might be inside of a module, you'll need to tell the developer what is your intent in there. For example, do you want to enable a switch? Do you need to do a conversion on the data? Is there things that have to occur inside of this case that you can't show and that would take too long to write out in LabVIEW? So you can put that short note in there for the developer to complete that.
So you would build, as the architect, you would build the state machine within the module itself.
That's right.
You would have the connector pane wired up so the data is able to be passed in. But then you would have to add documentation to each of the different functional areas you need a developer to fill out, like the different cases in the case structure, but you wouldn't be filling them out yourself in this exam.
That's correct.
Okay.
So filling out each of the detailed cases is a developer level task that we look for. The architect, we're allowing you to pass it on to your developer team.
Yeah. So
also, the hierarchy for these modules should be related. So for example, if you have a display console and you have a user interface console, you don't want those sub-VIs mixed together in your hierarchy. You want to have separation within your hierarchy, or within your project, of course, for those different modules. That makes it much easier for developers to understand what is the area that they're working on, and that ability to spread that out to the different developers. You can see here we've listed some of the modules that you might encounter. Database or file handling, the error handler we've talked about quite a bit, and timing, for example.
I'm sure error handling catches a lot of people up, because having that modularized and be able to communicate back up to the main VI and handle all the errors, that's a pretty big strategy jump from a CLD to a CLA level.
That's right. In the CLD, the error handling is very straightforward. In the architecture level, we're expecting, and keep in mind that we're looking at you having had a couple of years of experience in the field, we're expecting you to be able to pass errors appropriately to a central controller that could then make decisions on the error if there are tiers or levels of the errors, as you'll see in sample exams, and for that controller to be able to then communicate back to the modules to tell them what to do based on the error conditions. So here we go in a sort of a pictorial view, what some of the main modules you might find. Now, you'll notice that we mentioned the GUI set. As we've discussed earlier, there will probably be more than one front panel that comprise your user interface. We have the error handling, timing, the database module. Initialization is an interesting module in itself. How do you initialize all of these other modules? Are you doing that in a way that when you substitute a hardware module, you have to do development to redo the initialization. So you want to think about that. In addition, the opposite of that, we want a smooth shutdown. We don't want one module to close and the other modules to start erroring out. We want the central controller to be able to talk to the modules and tell them when it's time to shut down. The communication module is a very important piece. That's sort of the high level that allows the architecture to be created. That is how the different components talk to each other. That's you showing us in your own way how you would have your modules talk with each other. So what is a module? We've talked a bit about that. It could be one VI, or it could be a series of VIs that work within themselves or work with each other. For example, in the ATM, transactions is a module. You have deposits, withdrawals, these sorts of things. Or, for example, a database module. Inside there might be file I/O or the ability to switch over to an embedded database. What that might mean is if your database is looking for its file, or if your database module is looking for a database itself and it can't find that, what is it going to do? Does it have some sort of hard-coded or default data that it would use? Also, it's possible that you might be required to have that database lock its records so that you don't have multiple access going on at the same time.
What's the benefit gain for having this type of modularity as a developer, having all the transactions be contained in one module?
What it allows you to do is to substitute other modules in. For example, we've talked about substituting a hardware module in. But another example might be, let's say that you have created a display console and the client or your manager says, you know, I really don't like how that looks. Let's make another one. Let's change it up a little bit. If you can just swap out the VIs or the VI team, so to speak, that is modularity. If you have to go in and instead start doing development in other modules because of your change, then you haven't really created a modular architecture.
So scalability and reuse are some main benefits of modularity.
Definitely, definitely. And it also, modularity allows you to give different components to different developer teams. Let's say, for example, you're pressed for time and one developer team doesn't have a lot of time. They can't maybe work on 2 or 3 modules. If you can spread that out, if these modules are self-contained, other developers can work on them without having to worry about the other pieces of the code.
Okay.
So in the modules, we're definitely looking for a well-defined API, the connector pane, the icon, and the messaging for that module.
And the API would be defined by the architect itself, so that way you can spread it out, the module development between different teams. They know how they're going to be able to interact because it's kind of a known entity of how they're communicating that API across.
That's right. It's a solid interface between, let's say, for example, the controller and one of the display consoles. That API, if you did not define the API as architect and you farmed out your modules to different developers, when they came back, you would have a hard time connecting them because everybody would have their own spin on how the messaging and how the data is transferred.
And the API is determined from the architect looking at the scenario and the functionality needed in the requirements and mapping that to a functional architecture and making decisions on whether to use queues or what type of error handling strategy, and then the architect defines that and the developers plug into that API.
That's right. They run with the API and develop the details. One small example would be transferring data. If you were making a deposit, if you were the architect, you might decide, I want that deposit amount to be a double integer. And a different architect might say, you know, I want a variant, and I'll just convert that when it gets to where I'm going. So those decisions have to be made by the architect and not left up to the developer.
Okay.
Let's talk a little bit and change our gears about requirements tracking. When you've been given a specification from a client and you've completed it, the client wants to know, well, how was that done? How did you complete all of these things that I want? Can you show that to me? So by using labels or comments, or what we're calling tags, you're able to go directly into the code to show your client exactly where that requirement is being met, and it can be evaluated. So for this exam, we're using this format that you see here with the brackets and the word covers, and then the code, for example here, U12A, that comes from the specification. All of these codes are in paragraphs of similar functionality. So for example, UI1 would probably be the user interface 1 requirements. UI2 might be the user interface 2 requirements. So they'll be grouped together. So you'll see in the sample exams there'll be shutdown requirements, timing requirements, initialization requirements, user interface requirements, and then a series of functionality requirements that are based on the scenario that you're working on.
And by being supplied the document in the exam, you're going to get around the issue that you set up a little fake issue here, but you can see it's UI 2A, but it says covers U1 2A. So by having the requirements, you'll be able to copy and paste that into your code, which saves us time overall. So that way, I'm a horrible speller.
Yes.
So if I spelled it incorrectly, if we were trying to use requirements tracking, which I assume you guys use requirements gateway?
That's correct.
If you were to do that and you're a horrible speller like I am, you could have covered the code, but if you spelled it incorrectly, it wouldn't be pulled in.
That's right.
So would you advise everyone copy and paste things from the actual requirements document into their documentation?
Yes, I would. So let me expound on that a little bit. In the specification, it's very clear what the requirements are, but we also provide for you an additional text file that has only the tags in it to simplify cutting and pasting those tags in. Then you don't have to worry about missing the semicolon. You know, that'd be like programming in C. Who wants to do that? So as you see, on the USB, when you take the exam, you'll be provided that text file. Now, requirements are a huge portion of the grade, so let's talk a little bit more about how it is proper, or the proper method to put those into the code. So first off, let's take a slide example here between a user interface and the controller. You as architect have set up some sort of intermodule messaging to communicate with each other. In this small example, we're showing two tags. One of them says that the indicator turns red when a process stops. So the indicator itself is going to be on your user interface. So it's important that that tag is placed on the user interface where the indicator is turned red. Now in the controller, for example, we were setting up this small scenario here where when the time elapses, the process stops. You see in both cases we're talking about the process stops. Well here, we're going to put in the controller, this is the requirement for the process stopping because time has elapsed. This in the controller is not the location where you would put the tag for turning red. Although the two are related, the process stops, then the light turns red, the tags are located in very different pieces of the code. So you want to pay attention when you look at the tags. There's sort of a level to these tags. Some of the tags are very generic. They're at the highest level. They might just be in your file properties. Some of the tags can be very detailed. For example, an LED turning red. That would most likely be found inside a case in the design pattern of one of your user interface modules.
So just for clarity, whenever you said that you need to put that tag on the UI, it's actually in the user interface VI, but on that block diagram where that actually turns it red. So
that's correct.
This would be in a free label or in a comment in that case structure where you actually physically turn that indicator red.
That's correct.
Okay.
And let me just go on that a little bit further. You might not actually write the code for the LED to turn red. You will probably be putting documentation telling the developer, turn the LED red here. You've already provided him with the design pattern so he knows where to do it. You've already created the messaging system so she knows how to process the information into the case. And so you'll see that there's kind of a relationship between where the tags are and where the documentation is. It's most likely that in most cases, when you're documenting to the developer, you'll also be putting a tag there.
Okay.
Let's look a little bit more on tags. You can see here two examples of two cases from a controller. And on the left side, you see multiple cases where you see in each place a tag has been placed. So it's very clear, for example, on the left side where all of the booleans are, that there's some sort of action occurring here covered by DC1 or DP1. On the right-hand side, it's the exact same code, but what we've done is we put all the tags into a free label and we put it up kind of on the higher level block diagram. That's not clear. By doing that, you're asking the grader or, for example, the developer that would be taking over to not only determine where the tags are, but to have to go back, read the tags, understand what the tags are, and then figure out where the tags are supposed to be. To a certain extent, that's kind of tag dumping. You're just throwing the tags down. That's not what we're looking for. We're looking for very specific detail of where these tags should be.
Would there be any points taken off for the tag dumping that we see on the right-hand side here that says not clear?
So that's a very good point. Let me answer that by going backwards a little bit. When we run the requirements gateway, we get a raw score of all the tags that are on the application. Then we go step by step using requirements gateway to look at each individual tag. When we're looking at a tag in Requirements Gateway, it shows us the text from the specification. For example, it might say the LED is to turn red. If we then go to the tag in the code and it's in some location where there's no information or there's no clarity, then the point will be deducted for that specific tag. So we go on a point-by-point basis.
Okay, so you want to set up the, if this was a real scenario, you'd want to be setting up the developers to be as successful as possible to take the requirement that you just gave them and turn it into actual code.
That's right. So in addition, it's important that as an architect, when you create your code, you might not have 100% of the tags done. It's important for you to know which tags still need to be worked on too. Let's take one more look here. Now, in some of the models, in some of the scenarios, there will be multiple states that are very similar. So, for example, we have deposit and deposit complete from the ATM. In the first state on the left, there's a lot of detail. Each of the booleans is set, the text strings are put for those indicators, and down on the bottom we see there's a couple of blank outputs to that case that aren't being used. Now, if you have multiple states, for example, let's say there's 5 other states, it would take a lot of time to go to that level of detail on each state. So it is very acceptable to do as we do in the second side, where we refer to the first state as the template or the example for all of the subsequent states, and then we put the tags in, and we would allow, that way you don't have to sit there and choose each individual Boolean. You can allow the developer to do that. Now notice also on the bottom, there is one difference. If there's a slight difference between the states, you're going to want to detail that out.
So I could see that as you're going through, there is the opportunity that you leave code in a non-functional state.
Oh, without a doubt, yes.
So is it acceptable to have a broken run arrow whenever you turn in your code?
Certainly, we expect that.
Okay.
Yes. So again, just to reemphasize, we're not looking for a running application here. We're looking for the framework for developers to complete that for you.
Okay.
Let's go to the next. Now, there's an important element to this exam that we're looking for. We do provide 2 sample exams for you to look at to see how tags are done, how documentation is done, how some sample architectures are done. These by no means are not training material. This is not National Instruments telling you this is how architecture has to be done. We're just showing you here's 2 examples. So following up on that, we're not looking for someone to come in and have memorized these examples and just repeat them in the test. So here, for example, we're showing a picture of an error handler, and on the right hand side in the block diagram you can see a lot of detail. If you were to come in and just repeat and replicate this example, we would not be able to give you points because you're not showing original work. You're not showing how you would architect the error handler. It would just be copying of a module. So we're just asking you not to do that.
And there's no one right answer whenever it comes to architecture.
That's correct.
So there's many different ways that you could do the ATM example as far as architecture and communication, but you're just looking for clarity on the decision making behind it and also setting up the developers for success.
That's correct. We're looking for you to show us some of your 1 to 2 years of experience that you've had working on large-scale applications and your methods for solving an architecture quiz.
Okay.
So the last section here is about the documentation for the developer. So the first bullet is asking you not to just copy or retype in the specification, because that is just asking the developer to do the job of interpreting the specification. So we are looking for specific individual instructions based on your architecture and the design patterns that you've created for your modules for the developers to complete the work. Some people might be, as an example again, some people might be using variant data structure. Some people might be using individual data elements such as booleans and doubles and integers. So obviously the documentation cannot be the same for those 2 architectures. So we're looking for your individualized documentation to the developer. It doesn't have to be a novel. It just needs to be very straightforward. Do this, enable that, transform the data here, that kind of documentation. And as I discussed earlier, there's a very close relationship between the requirements tags and the documentation, because each case that you make has its intent and its purpose. So once you've created that case, give yourself the points by going ahead and putting in the tag for the requirement that case fulfills and a short, brief documentation for the developer on completing that case. So we're going to move on. We've discussed the details of the architecture exam, what we're looking for, the tags, the general architecture, some detail about the modules, the module design pattern in architecture, the data communication between those. We've talked a little bit about the error handling. We briefly touched on timing, creating a timing module. So let's take a little bit of a look at how to prepare for the exam. So we have a great link, very easy to find, ni.com/CLA Prep. That will take you to what we call the eKit page. That gives you access to the sample exams and the preparation guide, as well as information on registering for the exam.
How much does the prep guide cost?
Well, that's great. We have no charge. It's very complimentary. We want you to pass, and we want to be as clear as we can. We love to tell you how we grade the exams. We won't get into the details of how the points are assigned, but we want to let you know how we are evaluating the exam. So there's no charge. It's complimentary.
Okay.
In addition to that, we have the NI certification forum, and we ask that when you create your sample code that you post it there and allow other team members or other community members to take a look at your code, to give you feedback, and maybe you could go ahead and take a look at some of their examples and give feedback also.
I learn a lot by looking at other people's architectures and their approach to things.
Oh yes, very much. In the certification forums, it's very focused, but in the forums overall at ni.com, a little plug for that, has been a great resource for me.
So on the kit, there's a preparation guide walking you through things to help you get prepared for the exam, as well as one or two sample exams to actually take.
So there are 2 sample exams available.
Okay.
So a few tips here. As we mentioned, the specification gives you a general objective of the scenario or the model that we're giving you. Then we have the UI, kind of the paper napkin sketch. This is what it looks like. Then we go into sort of definitions and terms. That gives you an opportunity in plain language to understand what this model is supposed to do, how this entity is supposed to behave. For example, the ATM. It takes a card. It allows you to press buttons to do transactions. You can look at your balance. If you try to take more money than is available, you can't get it. Those kind of things. Then it goes into the detailed specifications. So take a few minutes to read through that. Understand in your mind what the model is supposed to be doing. That'll help a lot once you dig into the details of the requirements.
You've talked a few times about that paper napkin sketch of what the UI was going to look like. In this time of planning your design and architecture, do exam takers have access to pen and paper to actually draw things out? Because you mentioned we're not allowed to bring anything into the exam, USB sticks or anything like that. So can we draw out?
You certainly can. So when you take the exam, you're given the USB stick. You're also given the specification printed out. So you can use the back of all of those printouts to write notes to your heart's content. The one thing to say is that those notes will remain property of National Instruments, but you're available and you'll be given a pencil also.
Okay.
So managing your time is very important. In 4 hours, you need to think for yourself, what am I going to do in those 4 hours? One pitfall you want to avoid is concentrating too much at the very beginning on the very first piece of your architecture. For example, let's say you wanted to start with error handling. You don't want to look up after an hour has gone by because you spent a lot of time really detailing out the error handler. So you want to try to start looking at the overall architecture that you're going to have. What modules are you going to have? Maybe create those modules as empty shells to get them set up, and then when you go back through, you can start developing them out. You don't want to get too focused too early on one little piece of your architecture. So managing your time is important, and I think that within about 15 minutes you should have read the spec in the first 15 minutes, gotten a good mental picture of what your model is supposed to do, what your scenario is, and then start diving into setting up your project so that you have your hierarchy, your modular hierarchy, and then you'll be able to start launching into creating all of your modules.
That's what 4 hours seems like a very long time, but it sounds like, based on your experience, it's not a lot of time.
It really isn't. It's not a time to be sitting and thinking about how would I architect. We're looking at your field experience and your time as a CLD, adding in so that when you start the exam, you always want to be doing something. You don't want to be trying to explore what you might do or some fancy way of setting up the architecture. So just like many certifications, for example, an engineering, professional engineering certification, the certification itself is not a reflection of what you do on your daily work. I'm certain that when we all create architectures, we have many days to plan all the details out. What we're looking for here is your ability to take the spec, to create this modular hierarchy, to create the shells and the stubs, and then to start filling those out to a level that allows a developer to take over. Okay. So 4 hours goes by very quick. Now, again, the passing grade is 70%. So we talked about the scalable hierarchy. Mm-hmm. Let's talk about advanced architectures for the main VI. Certainly, you could create a CLA scenario in one UI, in one VI. But that's not very advanced. To put everything in there, it wouldn't be modular, certainly wouldn't be scalable.
It'd be hard to read.
Yeah, it'd be hard to read. So we're looking for that ability to split out the modularity, the functional modularity, into different groupings and the messaging between those. So if you want to do active framework, if that's what you do all the time, that's a great way to go. If you're very familiar with using object-oriented and you're comfortable with that, that's fine too. If you're using traditional LabVIEW, that's what you should use. So you want to use what you're comfortable with, what your experience brings to you to the table. Just using active framework itself doesn't mean that you're using advanced architecture. It is advanced, certainly. It's a complex method, but in and of itself, it does not allow you to pass any more than just using a template in the CLD makes you automatically pass. You have to be able to use that in an effective method.
So for traditional LabVIEW programmers, you could solve this by setting up a state machine, essentially, if the exam and the specifications allowed it.
That's
but
correct.
That could be a solution here.
Yes. So I would expect that your controller module will be a state machine. All of the modules are generally a sequence of events, a sequencer, so to speak. And so it's most likely that you'll be using a state machine as your controller, and then within each of your UIs, you'll have a design pattern that will most likely include a state machine of some form or fashion.
Okay.
So abstracting and modularizing your functions. One module should perform one function. You don't want to have your controller and one of your UIs put together in one module. It makes it almost impossible to swap those out. For example, going forward, if you were to replace your simulation controller with a hardware controller, you'd have to do a lot of development to get that UI out of the controller and recreate that UI separately. So we're looking for that modularity.
So trying to get away from that coupling effect.
Yes, we want very loose coupling.
Okay.
And then documenting the main VI and modules with the requirements IDs. You've taken the time to set all of this architecture up. Reward yourself with points by making sure that you put in the requirements tags that are being fulfilled in those sections.
And I guess at some point you'd want to breathe during the exam.
Yes. I think I need to breathe a little more myself. You definitely want to pace yourself. If you get hung up on an area, move on to another area. When you start the exam, if you've set up sort of your hierarchy and you know what your modules are going to be, and you're working on a particular module, if you're going fast and everything's going smooth, finish it out, move on to the next one. If you feel kind of hung up or there's some detail that's bothering you, you should be able to switch gears and move to another module and continue development. So what happens after the exam? The proctor will send the exam to us here in Austin for evaluation. As we mentioned, it'll take about 4 weeks to turn that around. 2 engineers will review the exam for the grading. Then, when you're successful, you'll receive a logo and a certification via mail. Now, at this time, the certification, recertification is 2 years, but I believe we're changing that. So pay attention, keep up with your branches, and you'll see that our recertification policy might be changing in the near future. Now, if you're not successful, and not everybody passes it on the first time, sometimes you have a bad day, sometimes a particular scenario can get the best of you. We see this in the CLD and also in the CLAD. Sometimes the luck of the draw just isn't with you. We give you feedback on the evaluation sheet that talks about the areas that the points were and were not awarded for that evaluation. And when you're ready to retake the exam, we'll be ready for you also.
And that's why we have 2 engineers looking over the exam to try and be as fair as possible, so it's not just one person's opinion and input on how an architecture should be set up. We actually have 2 engineers getting together to figure out what the score is.
That's right. And we have a lot of what we call intra-grader consistency. We have a checklist that's very long that goes into detail. Each individual tag is reviewed, each of the documentation areas is reviewed, and each of the architecture areas are reviewed. For example, if we're looking at inter-module messaging, we'll see how is that set up and how is that done and evaluate it. So,
could I get a hold of that checklist, or is that the secret sauce that we're not allowed to have?
well, I would look forward to a CLA Success package that's coming out. At the time you're listening to this, it may already be available.
Okay.
So we've gone through preparation for the CLA, and I want to remind you to go to ni.com/CLA Prep to get all of your preparation material, the preparation guide, sample exams, and you'll be able to look at the forums to work with other community members.
Great. Thank you.
Very good. Well, thank you, Grant. I appreciate you giving me the time to set up this preparation guide for all of our customers. And if you have any questions, please send an email to
certification@ni.com.
Yes, thank you. I was a little turned sideways there. All right. We look forward to having everybody send us any questions.
And if anyone else has any questions they want to ask other community members, going to ni.com/CLA Prep and then linking over to the certification forums, they can ask questions, post code, get feedback. All of that can be done there as well?
Yes, that's highly recommended.
Okay. Thank you so much.
You're welcome. Thank you for having me.